In programming, a variable is a container that stores a value that can change during the execution of a program. The variables have a unique name and a type of data that defines what type of values can contain. In Unity, the variables are used to store and manipulate data in games development. They can be used to store information such as object positions, scores, game settings, among others. Here you have a basic example of how variables are defined and used in Unity. In the previous example, several variables with different types of data are defined. The private modifier is used to indicate that the variables are only accessible from within the class in which they are defined. The public modifier is also used to indicate that the player object variable can be accessible from other scripts or components in Unity. Within the start method, values are assigned to the variables and operations with them are carried out. For example, the score plus equals 10 is increased, the player's name, player name equals new player, is modified. And it is checked if the game is over, if is game over. Variables can be used in different contexts, such as conditional, mathematical operations, securities assignments and more. They can also be used to interact with Unity components, as shown in the example by modifying the position of the player object. The variables are fundamental in programming and are widely used in Unity to store and manipulate data in games development. In Unity, a Boolean bool is a type of data that represents a true or false value. It is used to store and evaluate logical conditions in games development. The way to define a Boolean in Unity is similar to that of other programming languages. Here you have a basic example. A Boolean variable is gameover is defined and the false value in the start method is assigned. Then, the Boolean variable is used in an if conditional to verify if the game is over. Depending on the is game over value, a message will be printed on the console. Booleans are widely used in the development of games in Unity to control the flow of the game, perform conditional actions and store play states. For example, they can be used to determine if the player has completed a level, if an enemy is active or if certain conditions are met to unlock a game function. An int is a type of data that represents an integer. It allows to store numerical values without decimal, both positive and negative. The way of declaring and using an int in Unity and C# is as follows. A variable, score, of type int, that is used to store the game score is declared. An initial value of 10 is assigned in the start method. Next, arithmetic operations are carried out with the value of the score variable, as multiplying it by 2 or increasing it by 5. Then, debug.log to print the value of the score variable and the results of arithmetic operations in the console is used. It is important to keep in mind that int have a limited range of values, so they cannot represent extremely large or small numbers. Float is a type of data that represents a floating point number, that is, a decimal number. It is used to store numerical values with decimals. The way of declaring and using a float in Unity and C# is similar to that of other types of data. Here you have a basic example. Float variables are defined as gravity and player speed, that represent the severity and speed of the player respectively. The values are assigned using the f suffix after the number to indicate that it is a floating point value. Then, arithmetic operations are carried out with the float variables to calculate the jump force and the distance that the player can travel based on gravity and speed. Finally, debug.log are used to print the results of the operations in the console. Float are used when numerical values are needed with decimals. Float are widely used in the development of games in Unity to represent coordinates in three-dimensional space, speeds, scales, physical forces and other values that require decimals. String is a type of data that represents a character sequence. It is used to store and manipulate text, such as names, messages, descriptions, and any other type of text-based information. The way of declaring and using a string in Unity and C# is as follows. In the previous example, string variables are defined as player name and greeting that store the name of the player and greetings respectively. The values are assigned using double quotes to indicate that it is a text chain. Then, the string's concatenation is performed using the plus operator to unite the greeting with the name of the player and is stored in the variable full greeting. Finally, debug.log is used to print the result on the console. String are widely used in the development of games in Unity to show text in the user interface, store players' data, interact with databases, and much more. You can also carry out various operations with the strings, such as concatenation, search for subcadence, upper and lower case conversion, among others. In Unity, a vector 3 is a structure that represents a three-dimensional position or direction in space. It is used to store and manipulate three-dimensional coordinates, x, y, z. The way of declaring and using a vector 3 in Unity is as follows. A variable, player position, of type vector3, is declared to store the player's position in the three-dimensional space. An initial value of 0f, 1f, 0f is assigned in the start method. Then, the components x, y, y, z of the vector3 is accessed using the properties x and z. You can also modify each component individually, assigning a new value. Finally, debug.log is used to print the values of the vector3 and its components in the console. Vector3 are widely used in Unity to represent positions, addresses, speeds, scales, and any other type of information related to three-dimensional coordinates. In Unity, a transform is a component that represents the position, rotation, and scale of an object in the three-dimensional space. Each object in Unity has an attached transform component that determines its location and orientation in the scene. The transform component is used to perform basic transformations into an object, such as moving, rotating, and climbing it. Through the transform, the position, rotation, and scale of the object can be accessed and modified. In the previous example, the transform component is obtained by calling the getComponent method in the current object. Then, the position, rotation, and scale of the object is accessed and modified using the position, rotation, and local properties respectively. In addition, current position, rotation, and scale values can be obtained using the same properties. In the case of rotation, Euler angles is used to obtain the rotation angles in the form of a vector object 3. Finally, debug.log are used to print the transform values. The transform component is essential in Unity since it allows to manipulate the position, rotation, and scale of the objects in the scene. This is essential to move, rotate, and climb the objects of a game, as well as to perform more advanced transformation operations.